Okay, so we're going to talk about simplifying radicals. And I guess just to be clear, what we are actually doing is we are dealing with, primarily we are dealing with square roots. So this is called a radical symbol. The number underneath, let's make it a 16. This number is called the radicand. And this is actually a square root symbol. Much like when we have an exponent or have a variable of x, there is an understood exponent of 1. This one has an understood index of 2. Okay, so usually we just don't put it in there. So a square root, square meaning 2, of 16 is going to be 4. This is called the root. The reason why this is called a square root is because square root of 16 equals 4 times 4. So there are 2, meaning squared. So there are 2 roots, or 2 factors rather, for 4. When you get into algebra 3-4, you might see, you will see, like a cubed root. So this tells you how many equal factors you're going to have. I'm looking for 3 factors that are the same that give me 8. That is 2 times 2 times 2. So the square root, or excuse me, the cubed root of 8 is just 2. Take one of the roots. There are some rules of radicals that you need to be aware of. So here's some things that you cannot do. You cannot. One, leave a perfect square. Under a radical sign. So I could not leave my final answer as a square root of 25 and box it because it's not simplified. 25 is a perfect square. So you would have to go one more step and tell me that the answer is 5. Sometimes you have the square root of 18, for example, and the square root of 18 itself is not a perfect square. However, the square root of 9 times the square root of 2 gives me the square root of 18. And the square root of 9, this 9 is a perfect square. So square root of 9 is 3. Can't do anything with this. So the square root of 18 breaks down to 3 radical 2. So there was a hidden, if you will, perfect square under this original radical. Another thing you cannot do is you cannot leave a radical in the denominator of a fraction. Okay, you cannot leave a radical in the denominator of a fraction. So, for example, you could not box your answer of that. This would not be an okay answer. You have to do some more steps, and it's actually called rationalizing the denominator. And that will be a separate video, rationalizing the denominator. So if we rationalize the denominator, we will no longer have a radical in the denominator. Okay, so if we rationalizing the denominator, we will no longer have a radical in the denominator. The third thing you cannot do is you cannot leave a fraction under the radical sign. So you could not leave an answer as excuse me, the square root of 2/3. Can't do it. Okay, so again, we would have to rationalize the denominator here. One thing I do want you to note, is that when you have a fraction underneath the radical, that you can split up your numerator and denominator. So the 2 is under the radical and the 3 is under the radical, and they are still both under the radical. Okay, so we'd actually have to do the rationalizing the denominator here as well. And rule number 4, this is, for our purposes, an algebra 1-2 thing only. And that is, you cannot have a negative number under the radical. Okay? When you get into algebra 3-4, you can. So for right now, if you end up with the square root of -12, just know you have screwed up, you have done something wrong, because that is the introduction to imaginary numbers. So you might want to just make a little note. This is dealing with imaginary numbers. Imaginary numbers that you will see in algebra 3-4. Okay, imaginary numbers that you will see in algebra 3-4. Okay, so let's kind of start doing some simplifying then. Okay, so in all of these, we are simplifying. It is no different than simply reducing a fraction. So if we had the fraction of 10/12, we would divide the top by 2, divide the bottom by 2, and we get 5/6. Okay? If you type this into your calculator, and you type this into your calculator, you are going to get the exact same value, because we are just simplifying it. Okay? We're not changing the value at all. We're not doing any adding, subtracting, multiplying, or dividing. We are just simplifying it. So if we had the square root of 121, square root of 121, I know is the same thing as 11. Okay, so you can think of this as a couple different ways. You could go through the factors and realize that it's 11 times 11. That is a pair. Take one number out and put it outside the radical. There's nothing left to put underneath the radical. So this is one of those perfect squares. So you should know perfect squares from 1 squared to 15 squared. Okay, so look those up, write those down. And you should definitely be able to recognize, maybe not so much memorize, but recognize 16 squared through 25 squared. Okay? Example 2. Let's do the square root of 18. We've already done this one, but we're going to add this in to your notes formally. So the square root of 18. I know it's not a perfect square. So I'm going to break it down to 9 times 2. 9 breaks down to 3 times 3 times 2. So you circle your pairs. I'm going to write these down in formal steps. Okay? So 1 prime factor the radicand. Remember, the radicand is the number underneath the radical. So prime factor the radicand. Circle pairs. Take one number from each pair. Take one number from each pair and multiply them together. Then I'm going to put in a different color. This number goes outside the radical. Okay. Fourth step, is all numbers not circled get multiplied and put back under the radical. Okay, so I circled my pairs, and I have a 3, so I take one number from each pair. I take a 3 out, and then I have nothing, no other pairs, and then the stuff that is not circled, which would be my 2, gets put back underneath the radical. So the square root of 18 simplifies to 3 radical 2. So if you want to check to see if you have done this right, you are going to, or you can, put this into your calculator and see what decimal it spits out. And then put 3 times radical 2 into your calculator, and it better be the same decimal. If not, you have screwed up. Another way you can check your work is to go backwards. So instead of doing a square root, we're going to square it. So 3 squared times 2 gives you 9 times 2, which gives you 18. And that is the number that we started with underneath the radical. So I know that this is correct. Example 3. I'm going to grab my handy-dandy calculator here for a minute. And I'm going to kind of skip a little bit, and I'm going to focus on like the last line, the prime factorization line. So let's say we we prime factor, and we end up with like a 2 times a 2 times a 3 times a 5 times a 3 times a 7. I'll chuck in another 2 there, okay? So, just so you know, 12 times 15 times 14. So this would be prime factoring the square root of 2,520. Okay, just FYI. But I want you to get practice on the steps. So we're going to circle our pairs. I have a pair of 2s, and I have a pair of 3s. So I take one number out from each pair and multiply those together. So I have a 2 times a 3. Then all the other stuff that is not circled gets multiplied and put back underneath the radical. 5 times 7 is 35. Times 2 gives me 70. So you have 6 radical 70. So hopefully, if I go backwards and check it and do 6 squared times my 70 that's underneath there, I end up with, oopsie, you can't see very well, end up with what you started off with. A very common error, and this is why I put this in red, is if we go back to this one, I will often see students switch these 2 numbers around and put 2 radical 3. Okay, so if you were to check it and go backwards, you'd end up with 2 squared times 3 gives you 4 times 3, which is 12, and that is not what we started off with, so I know that this is going to be wrong. Okay, just make sure that you are checking your work. Let's see, let's do one more example, example 4. What I would probably suggest you do is to pause it, try it on your own. Okay, I want you to pause it and do the square root of 30. So square root of 30 breaks down to 5 times 6, 5 and a 2 times a 3. There aren't any pairs. So if there's not any pairs, then I can't pull anything out. So that means there's no number to pull outside the radical. So in other words, there's no perfect squares in here. So if I multiply this and put it all back under, I still end up with the square root of 30. So the square root of 30 is simplified. So every once in a while, you'll find those big prime numbers that cannot be simplified. Don't panic. It's just the square root of 30. Again, I want to have you try this one. Do a little bit larger number. Have you do the square root of 108. So pause the video, Try this on your own and see how it goes. 108 breaks down to 3 times 36. So I have 3 and a 6 times a 6. I already have a pair, so I'm going to stop there. Okay, I could break it down more, but I don't need to. So I end up with 6, radical 3. I'm going to check that. So if I square it, so this is my check. I have 6 squared times 3 gives me 36 times 3, and that does give me 108, which is what I started with. Again, another thing you can be doing is trying it this way and to break it down into different radicals. So square root of 108 is the square root of 3 times the square root of 36. Square root of 36 is a nice, neat 6. Because this is not under the radical, we put it in front. Okay, so it's going to be 6 radical 3. It's absolutely no different than we do not write x2, for example. We write 2x. We put the coefficient up front. Okay, so there's some practice problems or some examples to help you simplify radicals.